What up, guys? Late night recording for Math 3. So, we're going to be helping you guys today with graphing exponentials, especially with Desmos, graphing calculator. But of course, before we do, got a new dog trick to show you guys. Here we go. Okay, come here, buddy. Come on. Come on. Let's show. Okay, ready? Good boy. Shake. Good boy. Okay. Sonium. Here we go, Max. Sonium. Good boy. Oh, you guys can't even see what he's doing. Okay, come here, buddy. Come here. Okay, here we go. Okay, ready? Sonium. Sonium. Good boy. Roll over. Oh, what a good boy. So we taught him that, which is pretty dang awesome. Also featuring something new here today. I don't know if you've seen this guys before, but this is a soda maker. What soda maker? It's called Soda Stream. And what you do is you make your own homemade soda. What? So you stick it in here just like that. I usually hold it under there just to give it some more pressure. Keep it nice and airtight. And then you do that a bunch of times. How many times? Well, that's 4, 5, 6. Ooh, that's a lot of pressure. 7, 8, 9, 10. As it gets older, you kind of have to do more. 4, I only had to do 6. But we're up to about 12 or 15 now because the bottle's almost empty. Oh, that was a good one. That was a good one. That was a good one. Okay, so then. Nice, look at that. It's bubbling away. See that? Bubbling away. You've got your root beer extract, as well as your diet for those of you that want, like me, lose a little bit of weight during this home time. And I actually like to mix a bit of both, you know. So I'll actually just do like half the diet, like so. That's it. And then we'll go ahead and top that off with a bit of the real stuff, you know, the sugary kind root beer. There we go. And then all you gotta do, so this is really easy. Definitely should get one from Walmart. There we go. And it's fun to make your own soda at home, right? So we have half 0 calorie, half whatever calories. I mean, on here it only says 60 calories, 16 sugars. So half that's only 8. That's not bad, right? That whole thing. And then last but not least, you go ahead and put the cap on like so. And Walmart should pay me for this, right? Showing how to use their stuff. Or SodaStream should. And then you just kind of mix it up a little bit. Like that. Nice. That's it. And then you're ready to go. Homemade root beer. Cheers. Well, that's the good stuff. Okay, so got my chair ready. I'm able to sit down now, which during the year I had real problems with that. But I got a big old shot. And that shot helped me to be able to sit down again, which I'm so excited about. Never been so excited to sit down. Because I couldn't for like most of the school year. Had to stand up all the time, which wrecked my leg. The insurance company won't cover that. Needed surgery. But I'm not complaining. Well, just a little. Alright. Okay, so we were helping you guys. Look at that. You like that? So where we were helping you guys was on exponentials, homework number 1. So specifically 3 things we want to talk about. I think we already did in the other video, but just in case. So growth, bacteria growth, starts low on the x-axis and goes up high to infinity and beyond. Then an example of that is bacteria, right? So bacteria grows exponentially. Okay, and then negative growth would be going the other direction, starting still at the x-axis but going down into the negative dollar amounts that you owe money because your credit cards. So that's called negative growth, or neither. And then last but not least, you start really high and you slowly go down, 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 down and decay to nothing. Radioactive! Okay, so using Desmos, the main reason hopefully why you're watching this. We already did 1, 2, 3, and a few others on the video on the first one. So we'll just jump to another one that hopefully maybe we haven't done if I can remember. So for example, number 5. So 4/3, 4 over 3 to the x power. So that's like a decimal, it's over 1, right? Because 3 over 3 is 1, so it's like 3 1/3. And if you keep timesing it by itself over and over, it's going to exponentially grow, right? So this is my hypothesis, and then we'll check our software to make sure that we're doing this right. So I'm guessing that if you plug in a 0, if it lets me. Oh, there we go. Okay, so if you plug in a 0, you're going to get anything to the 0 power is just 1. There you go. So I'm guessing this is just going to exponentially grow. Probably need to be more exact than that, so we'll jump over now to our website. Okay, so www.desmos.com is the website. desmos.com. You're going to need this for this and logarithms. You can use it on the practice test, on the test. Definitely. Thought there's a mosquito on me. Getting paranoid. Okay, so you hit start graphing next. Awesome. And then you just basically type it in. So what are we trying to graph right now? Well, f of x, or in other words, y, is equal to parenthesis 4/3, or 4 divided by 3, to the x power. So when we say to the, that's the exponential symbol. And so I believe on your keyboard there, that's 6, but it's actually like shift 6, I believe. So yeah. So shift 6 is going to give us the exponential little thing here. So we'll show it to you right now. So you can go shift 6 and raise it to the x power. Okay, so we go back to Desmos, and so we're going to go to y. That's it. Equals, and then remember we're going to do. So I'd like to do like a parenthesis, which is shift 9, and make sure you do parentheses actually, just to make sure you get this right. So then you do 4 divided by, right? So 4 divided by 3, good, which is 1.33, good. I do a right arrow, and then do a shift 0, which will give us the closed parenthesis. Then you need to do shift 6. And so you're going to notice my little bar that's blinking there is going to jump up a little bit. Watch, ready? So shift 6, boop. So now it's an exponent, right? Exponent. And so then we're going to go ahead and just hit x now. Boom. So there's the exponential growth. You can see here at 1 is where it climbs. Looks like it's more of a slow grower. A slow grower right there. Because when we get over to... There we go. So if you click your mouse, you can kind of drag up and down on it. And so you go over 4.05, so over 4, and then you're going to go up to, what is that, 3.16. So basically what that means is 4 over 3 to the 4th power, where x equals 4, is barely just going to jump it up to 3.16. So it is a slow grower, but it's still definitely... This is going to be growth. So if we want to be more exact on our graphs, we can go over 1, 2, 1, 2, 3, 4, up 1, 2, 3.06. 3.16. Cool. So I'm going to go and erase this a little bit to be more exact with us there. Okay. And then like we said, at 0, 1, it's good to identify or make sure we got the y-intercept right. So at 0, 1 is where that crosses. So it's going to come along, it's going to go through that 0, 1, and slowly, but the exponential growth still, but ever so slowly compared to some of the rest. And so the horizontal asymptote is just going to be here at 0. And then what you'll learn on these ones is these horizontal asymptotes are going to go up or go down. So that'll be like a positive 3, that'll be like a negative 2. And that means it actually shifts it 1, 2, 3. And so your x-axis basically goes up 3, like that. And so we'll show you that one, 2x plus 3 using Desmos. So now we'll go over here. We'll just change this actually. And we'll go in there and delete it and make it a 2. And so you can see that's 2 to the x power. But what if we have a 2 to the x power and then a plus 3? Woo. So now you get a shift upwards of 2, 3. I think you can push control and zoom in. Should we try that maybe? Ooh, there it is. Cool. So, yep. So at 3, you're going to start. That's like your new x-axis. And then you're going to go up. And at 4 is where it's going to cross at 0, 4. And the reason why is if you plug in a 0 for x, 0, 2 to the 0 power is just 1, and 1 plus 3 is 4. So that's why it's going to be 0, 4. So we go back there now. And so we're going to go here, and then at 4 is where it's going to skyrocket. Cool. And so exponential growth, we'll try to be a little bit more exact. Let's see if we can. Looks like it goes over 1 up 5, over 2 up 7. Let's see if we can do that. So over the right one, up 5. So over 1 up 5. So we need to go a little bit higher. And then 2 up 7. So it's actually growing a little bit faster than I put on my graph. But it's going to be matching, so I wouldn't worry too much. Wouldn't worry too much there. Looking good. Cool. Now another one we want to just look at, which I think I've already done with you on the other video, but just in case, I don't think I did a decay one. So, so let's look at one that might be decay. So for example, where's a decay one? What do you think a decay would look like? So I think a decay, possibly, let's see, what could a decay? So you think something like a fraction maybe, decay? Less than 1, or maybe something negative. Let's take a look. So maybe, for example, 5's really close. 5's really close there if it was just a half to the x power. So let's just show you that on Desmos real quick since we're kind of doing a little lesson here with you. So for example, if you did 1 divided by 2 like that, to the x power, get rid of our plus 3, the shift up 3. Yeah, so there's decay. See, that's definitely going downwards, decay to nothing. What happens when we put the negative there for that problem is that it's actually, if I can find the right button, there it is. So it's actually a negative growth. So negative 1/2 to the x power is actually going to be negative growth, which I think I showed you in the other one, I believe, right? That it actually, negative growth, cool. Let's see, well, where's our decay one? I know there's a decay one in here somewhere. Is it this one? Maybe. It looks familiar. Negative 2, x minus 1. Let's try that. So negative 2 to the x. If I can go up, there it is. I'm going to move around a little bit with your program. Minus, nope. So we have a x. And then we do a minus symbol. I wanted to stay there, so I'm going to have to do shift 6. Nope. Let's do shift 6. Ah, it's back up there now. So, no, I want a negative. Okay, so I'm guessing you're going to have to put in parentheses. So parentheses, then an x minus 1. There we go. So decimals is a little bit tricky there on that one. Okay, beautiful. So let's double check that we did this one right. Negative 2 to the x minus 1. So negative, got to do parentheses there, 2. And then this also parentheses. So negative 2 to the x minus 1 is what that one we're looking at there. Negative 2 to the x minus 1. Cool. So that one is definitely negative growth. It looks like at negative a half is where the y-intercept is. So we're going to say this is decay. Wait. Yeah, no, this is negative growth again. Dang. So this is still negative growth, or neither. Negative growth. Man, where's my decay at? I know. I wonder if I only have one in here. That'd be crazy if I only had one. That's interesting. And is it this one? No, because that's going to flip it to be 1 over. It's going to negative be 1 half, or this would be 2 to the positive x power. No, I don't see it. I wonder if I changed this on your worksheet and I don't even remember. Let's see. Let's see here. Let's just take a look. I thought I had like I just changed 13 to be yours. Let's just take a look real fast. So 13, we wanted it no. We wanted 15 to be decay. So I think on your worksheet it's actually number 15 has, we just changed that to a positive. That's the ticket. Sorry about that. Okay, so then we'll go back to number 15. Yeah, so we just changed this to positive on your worksheet, I believe. And then this one, and then this one is going to be, yep, that's going to be decay now. Cool. So now you've seen a decay one. Awesome. So 15 is not decay. No. I mean, 15 is not negative growth. 15 is definitely decay. If you could see my eyes, they'd be red right now because I'm really tired. But I still wanted to help you. Make sure you know how to do this. So last but not least, there we go. We'll just go back here. We'll make this go away. So now it's y equals, get rid of the 2, 1 divided by 2 to the x power. Now we have decay. Nice. So we start off high, like exponential growth, but going the other way. So it's going to be 4, 3, 2, 1, a half, 1, 0. Oh, a half. And actually never goes to 0. It gets really close. If you were to check this out, it gets really close. Even though it says 0 there, it gets really close, but it actually doesn't cross the x-axis. And so it decays to almost nothing, like uranium. Radioactive. Nice. Okay, so then last but not least, I'm just going to double check this for you guys. And so you can turn it off now if you want to, but I'm just double checking. So number 15 should be a positive 1 half to the x power. And so that means then that that'll be your decay problem. And so I wanted to make sure to include that in this assignment just so you've seen growth, negative growth, and decay. Sweet. Okay, so that's loading. Whoa, you see my house and you see me this whole time? That's cool. Woo! Awesome. And it's still loading. And this is a long video. I didn't mean it to be that long. Sorry, guys. But thanks for watching. And always feel free to fast forward, rewind, skip through my videos, check your answers, and learn. So definitely thanks for watching. Okay, so we'll just double check really quick there. So number 15, yeah, so we changed that to positive. So sorry about that. 15 is definitely decay, but all the other ones are like growth and negative growth. Cool. Thanks for watching. Peace out. Thanks for watching. Peace out. Woo! Yeah. Go Warriors. There it is. Punt kick. Ooh. Thanks for